Good morning, young scientists. Today we're going to learn the cloud model or quantum mechanical model or modern model of the atom. There's no change in the nucleus, so grab a piece of paper and you need 4 different colors and we're going to draw some pretty pictures. So first we're going to start with the nucleus in the center of our paper. Draw it kind of small. There's no changes in the nucleus. The nucleus was known about as early as the 1800s. They had discovered the protons and the neutrons. What's different about the cloud model is the arrangement of the electrons. So let's get into it. If we look at electrons, they are actually organized into cloud shapes. And there are usually 2 electrons paired in a cloud. We collect these clouds in shapes called orbitals, and the orbitals can hold a maximum of 2 electrons. So same nucleus, but electrons are in orbitals called clouds. These orbitals are organized into sublevels, and the sublevels are designated with letters. So if you have an S sublevel, it can hold 1 orbital, and the shape of that orbital will be spherical. And so the S sublevel with 1 spherical orbital can hold a maximum of 2 electrons. And here's the cloud that I've drawn around the nucleus. These are the electrons in the lowest energy level. They're going to be in the n equal 1 energy level, and that would be the principal quantum number 1. So in our configuration for electrons, we designate those electrons with a configuration of 1s2. If there'd only been 1 electron, we would call it 1s1, but since there's 2 electrons, we call it 1s2. So the 1 is the principal quantum number, or you would know it as the energy level. The s is the sublevel. And since this sublevel only has 1 orbital, which is a spherical orbital, we just show how many electrons there are in that orbital as 2, and we're finished with that sublevel. So the first sublevel only has 1 orbital, and it is spherically shaped. Let's look at the second energy level. The second energy level has 2 sublevels. The first one is an S. We can see again, this is spherical. S sublevels are always spherical. There's only 1 orbital. They can hold 2 electrons. Again, the same rule applies here. But now our configuration has grown. We had 1s2, and then on top of that we have 2s2. So in the second energy level, we so far have 1 sublevel. It's an S sublevel. It has 1 orbital, and it's holding 2 electrons, and it's spherically shaped. So our cloud model is getting bigger every time we add another energy level. Okay, let's look at the next sublevel. So now we have another sublevel. This is a P sublevel. These are little dumbbells, and there are actually 3 dumbbells. They're oriented horizontally, vertically, and then into the page and out of the page. So they are called P. They are dumbbell shaped. They can hold a maximum of 6 electrons. Since you have 3 different dumbbells, each dumbbell cloud can hold 2 electrons. And now our configuration has grown. Now our configuration is 2p6, because we've added into our second energy level, we've added 3 orbitals, and each orbital can hold 2 electrons, and they are dumbbell shaped, so we're designated them as the P sublevel. Let's look at our next one. So there's only 2 sublevels in the first energy level, and now I'm switching colors to red because we're in the third energy level, and we're going to start over. The third energy level can have 3 different sublevels. The first one, again, is spherical. It's an S sublevel. There's only 1 orbital that can hold 2 electrons. So our configuration has grown now to 3s2, because in the third energy level, we have 1 sublevel, and it's a spherically shaped orbital that can hold 2 electrons. So continuing to grow here, we're adding in our next sublevel, and we have a horizontal orientation, a vertical orientation, and I've actually left out the orientation that's into the page and out of the page. But there would be 6 electrons in these dumbbell shapes. Each dumbbell shape can hold 2 electrons, and the clouds, the dumbbell shapes are called orbitals, and together the dumbbells make up the next energy level. So the next energy level is 3p, 3 for principal quantum number 3, p for the second energy level, and 6 because those 3 orbitals can hold a maximum of 6 electrons. And now we have a prettier picture. Wow, it's getting big. So in the third energy level, there is a third sublevel. It's called a D sublevel, and it is actually 5 cloverleaf shapes. And notice I've drawn these cloverleaf shapes with a little bit more energy. They go out a little bit further than the S's or the P's, and that is important, so make sure that you do that. And now our electron configuration has grown to 3D10, and I've made a note here that we have a new shape. We have a sublevel that's a cloverleaf shapes. It's called the D sublevel, and there's 5 cloverleafs in the D sublevel, or 5 orbitals in the D sublevel, so it can hold a maximum of 10 electrons. And we won't keep going, but this goes on and on and on and on. Now, I did want to mention that when we get to the 4th energy level, there's some overlapping that starts to take place. So the first sublevel is a spherical sublevel, but notice I've drawn the edges of my 4S sublevel between my 3D and my 3F. It's kind of in the middle. There's actually some overlap. The electrons that are in the 4S sublevel actually have a little bit less energy than the 3D sublevel. So when we draw them, we have to draw it a little bit smaller. So this is going back to the 4S. So there would be 1 sphere, and it would hold 2 electrons. So our configuration now has grown. So we had 3D10. Now we're adding 4S2. But when we write configurations, we usually write them in the order of the energy the electrons contain. So when we write configurations, you actually have to put the 4S sublevel before the 3D sublevel. And then that gets a little bit confusing, but I'm going to show you a little trick to help remember that. So let's recap here. Oh, there is let me mention, there is a 4th possible sublevel, but it's a weird shape, and it's different shapes, but it holds a maximum of 14 electrons. So there are 7 of those orbitals, but we don't name the shape of them, but there are 7 of those orbitals. So it kind of goes by odd numbers here. The first energy level has 1 possible orbital in it. The next energy level has S's and P's, so there's 2 energy levels. And then the third energy level can possibly hold S, P's, and D's, and then the 4th energy level can hold S, P's, D's, and F's, and it never goes beyond that. So I'm going to show you a little trick to remember the order that these electron clouds fill in their electrons. So if you just list, remember there's 7 rows on the periodic table, so if you just list 1 through 7, and then you list the order SPDF, so the first energy level only has 1 sublevel, it's an S sublevel. The second energy level has an S sublevel and a P sublevel, so it has 2 sublevels. The third energy level has an S, a P, and a D sublevel. The 4th energy level has an S, a P, a D, and an F sublevel. That's the weird shape we don't name, and then it never goes past that. So it never goes past the F's. So for the rest of your energy levels, you can just put SPDF, SPDF, SPDF. Now to remember this order with this weird overlapping thing, draw diagonals. So 1S gets its own diagonal, 2S gets its own diagonal, 2P, 3S, 3P, 4S, and there's where our overlap was. If you guys remember, our overlap should have been 3P, 4S, then 3D, and here's where our overlap is in this order. So this is a little, if you follow the arrows, that will help you know the order that electrons fill in the configuration. So 3P, 4S, then 3D. So when you get to the bottom of your arrow, go back to the top of the next arrow and follow the arrows in your configuration. I'll show you how this correlates to the periodic table when you get back to class. Thanks so much. Bye-bye.